In this lesson, we are going to provide data to UI. We already fetched this data from the API, the model, and now we want to provide it to the view. And we'll do it by building the ViewModel layer. ViewModel has some juggling to do. It needs to keep the UI responsive, by which I mean not freezing the UI, while at the same time fetching the data from the model. And that's where a concept called multi-threading comes to the game. Multi-threading allows a program to run multiple tasks concurrently, kind of at the same time. So what is a thread? A thread is the smallest unit of execution in a program, and multiple threads can run in parallel in one single process. Hence the name of multi-threading. And in Android, multi-threading helps to offload time-consuming operations to keep the UI responsive. For example, fetching the data from the server on one thread while keeping the UI responsive on another thread. And that thread is called main thread in Android. Main thread is responsible of the UI. Imagine you enter a coffee shop where one person is doing all the jobs. So taking the orders, making the coffee, and serving them. You will have to wait a long time in the line just for your order to be taken, and then longer to just wait for the coffee to be served to you. This is the non-responsive UI. Multi-threading would look like having 3 workers. So one of them takes the orders, one makes the coffee, the other one serves it. All in parallel doing 3 different jobs. So 3 threads in a way. So in that app, you get efficiency and responsiveness. In modern Android apps, to implement multi-threading, we have a really powerful tool called Kotlin coroutines. This is a tool to handle multi-threading in a simple, clear, and efficient way. Coroutine is non-blocking, meaning that it doesn't block the main thread. So each coroutine suspends itself to free up resources while waiting for operations, for example, for a network request. Coroutine follows a structured approach, meaning that it's tied to scopes to manage their life cycle automatically. Imagine you leave that coffee shop because they are so slow and they are still preparing the coffee for you. Maybe they should stop. That's what gets handled automatically by coroutine. So it's tied to life cycles. It knows when to fetch data and when to stop. So Kotlin coroutine allows you to start a background task, pause them when waiting, suspending them, and resume them when the result is ready. It's showtime again. So do you remember the fake store API that we left it with this error saying suspend function can only be called from a coroutine? That's because Ktor, the library, uses coroutines under the hood. This function needs to be able to suspend. So we need to add a suspend keyword here. That's it. And we will use this in the view model. Now let's build the view model. So I'm going to create a new package called ViewModels. And here I create a new file, product ViewModel. This is the ViewModel for our product screen. Android provides us with a ViewModel base class to make things easy so we don't have to reinvent the ViewModels from the scratch. So I'm going to extend this class from the ViewModel class. And it's complaining that it needs to be initialized here. So this is how I initialize it. Now this ViewModel needs to connect the fake store API to the product screen. So I'm going to define the fake store API as a class property here. And I want to call this getProduct function when the screen initializes. So that's also when the ViewModel initializes. And in Kotlin, init block gets called at the initialization of the class. So I call api.fetchProduct. And I need to pass an ID. For now, let's just pass ID number 2, but later I'm going to make this dynamic. It's complaining again that suspend function should be called in coroutine. So you remember we said coroutines are tied to scopes. This is where we need to run this function, this suspend function in a scope. And ViewModel base class, it gives us that scope. ViewModel scope. And the way to run a suspend function in it is with launch. So we launch this suspend function in this ViewModel scope. In this way, this suspend function is tied to the ViewModel scope, meaning whenever the life cycle of the ViewModel is over, the suspend function will stop. And the beauty of using Ktor library is that it knows that the API call has to happen in the background. So it doesn't run that suspend function on the main thread. So now what do we do with this response? Why not just do this? I define a public variable and update it here so that the view can access it. Now the problem with this is that it's not reactive. Remember when we talked about compose being reactive, that it reacts to the change of data. So at this point, we don't notify the screen that the data is ready or the data is changed. Of course, we can take a callback or a listener from the view and just call it here. But we have a nicer tool for this in Android, which is called Flow. Flow is a tool that helps us work with streams of data that change frequently or arrive slowly. It's a part of coroutines. It's like a pipeline that delivers data bit by bit. So there is a publisher that publishes data, and there is an observer who observes the data. So in our case, the publisher is the view model and the observer is the view. And Flow delivers the data and also notifies the view whenever data is changed. So the benefit of Flow is that it's reactive. Remember that we said compose is also reactive. So they work really well together. And also it caches. So the data that we fetch from the server is going to be cached in the Flow. Now let's use the Flow in the view model. I'm going to remove this property and define a flow. So we're going to use a type of flow, which is called mutable state flow. Let's break it down. So what is state flow? It's a state holder flow. So it holds a state in itself. Compose works well with state. So compose screens and composables, they want to know which state they are at. Is it a loading state? Is it an error state? Is it a success state? And etc. So this is why a state flow is a common way to provide data to composables. And then what is mutable? So by default, you cannot change the value of a state flow, meaning that the value is immutable. But to be able to change the value, we need to make it mutable. So that's why we need a mutable state flow. And then we also need to specify the type. So what type of data will this flow hold? And that is, in our case, product. So we want to deliver product as a data. And then I need to initialize it here. So it's going to complain that no value is passed. How state flow works is that it has an initial value at the beginning. And when I have no product at the very beginning, that value is empty. So in Kotlin language, null. And is going to complain that it cannot be null because this product isn't nullable. In Kotlin, we have this null safety feature that when you specify a type as not null, you will get a compilation error like this if you happen to pass a null value. So how to make it nullable is with a question mark. And how do we update the data? We update the value. This is how mutable state flow works. And you know, to make it a bit nicer, I want to extract this part to its own function. And I can make this part even more concise. So in Kotlin, you can use the equals for a function like this. So that's it. This is our view model. This product is now public, ready to be used by the view, which we will do it in the other lesson. So the key takeaway of this lesson is that Kotlin coroutines is a tool to handle multi-threading in a simple, clear, and efficient way. And Flow is a tool that helps us work with streams of data that might change frequently or arrive slowly. And so the action item is to implement the view model.